Good. So now I will distribute because this is linear. So x plus 6x minus 27 equals 8. Combine like terms, 7x, and move 27. 35, very good. So then x equals 5, very good. Now I have to go back and replace x because I also need to determine y. Just finding x is not good enough. I have to find y as well. So let's find y. So with x equals 5, I go back here. 2 times 5 minus 9. How much is that? 1. So it appears that the solution is
5, 1.
yes. Do not trust the solution yet. We have to go back to the original problem and plug it in. So I go back and plug it in. 5, 1. 5, 1. 5, 1. Yes. David, go ahead.
Yeah, I remember this from something.
I feel like I've done this before in my life.
Yes, of course. Yeah.
And did this for, when we put the 5 in the x.
Yes. 2 times 5 is 10. 10 minus 9 is 1.
Oh,
So we expect the solution to be 5, 1, but we don't trust it yet.
don't trust.
Don't trust it. So then I had check. 5, 3 times 1 is 3. 5 plus 3 is 8. Check. 2 times 5 is 10. 10 minus 9 is 1. Check. So I know for sure that this is the correct solution. And no one can find another. Good. So you pick the other one, 21. Okay, very good. Let's take a look. 21. I see it. Okay, if you say so. So 2x plus 3y equals 6, and 2x minus 3y equals 6. It is, I agree. So then after this, I'll have to pick one myself. You can be trusted. Just kidding. Just kidding. Just kidding.
Gotta have victory once in a while.
Just kidding. Just kidding. Okay, so in this particular problem, we are asked to use elimination. And the question is, which one will I eliminate? Well, it is a simple problem. I don't have to do anything. I only have to add term by term. Why? Because I noticed that when I add term by term, the 3y with the negative 3y go away. So this is 4x, and this is 12. And when I divide by 4, I get x equals 3. Now this is good, but it's not good enough because I have to find the other variable. It doesn't matter which equation I go back to. So if I go back here, I have 2 times 3, which is 6, plus 3y equals 6. 6 and 6 go away. So then 3y equals 0. How much is y? Of course. So then what is the solution that I have to go back and test? 3, 0. Don't trust it? Not yet. So 3, 0, and 3, 0. Let's check. 2 times 3 is 6. 3 plus times 0 is 0. 6 plus 0 is 6. Yes. 2 times 3 is 6. Negative 3 times 0 is 0. 6 minus 0 is 6. Yes. So I'll have to come back and say 3, 0 is indeed the solution. Yes. Lindsay? No, that's good. Okay, allow me to choose another adding method. Yes, 24. Which one?
18.
18 is not the adding method. That's okay. So 24. In 24, we have 2x minus 7y equals 2, and 3x plus y equals negative 20. In this problem, I'm asked to solve the adding using the adding method. How do I make a decision which variable to eliminate? Here's the decision process. I look at the coefficients of x, 2 and 3. If I decide to eliminate x, I need to multiply both equations, one of them by a negative number and the other one by a positive number. that will eliminate, that will give me the same number but opposite, and so I can cancel x. I'm going to look at y now. The top one is negative 7y, and the bottom is y. Oh, okay. If I multiply only the second equation by if I multiply it by 2, negative 7y plus 2y will not be 0.
By -7.
By positive, because I already have the negative. So yes, because it simplifies things, I only multiply one equation by a number. I prefer eliminating y. Does it matter? No. If you eliminate x and I eliminate y, we'll get the same solution eventually. Doesn't matter. But it's easier if I only multiply one equation by a number. Everything term by term. So 2x minus 7y equals 2, and the next one is 21x plus 7y equals negative 140. And now, yes, that was my target. My target was to eliminate y. That's the reason why I multiplied the second equation, both sides, by 7. Because it gave me the exact opposite of that term. That's why I know they're going away. And now I perform the calculations I see. So then I have 23x, and this is negative 138. When I divide both sides by 23, I get that x equals negative 6. So I have x equals negative 6, bless you. So I go back anywhere you want, it doesn't matter. Let's say I go back here with negative 18 plus y equals negative 20. So what should y equal to?
-2.
Very good, because I'm adding 18 to both sides, so this is y equals negative 2. So what is the apparent solution? I don't know, don't trust it. Negative 6, negative 2, it comes with a question mark. I haven't tested, I have to go back now. So negative 6, negative 2, negative 6, negative 2. Ready? 2 times negative 6, negative 12. Negative 7 times negative 2, positive 14. Negative 12 plus 14 is 2, yes, indeed. And negative 18 minus 2, negative 20, yes. So I know for sure that this is a yes. And no one can find another solution. Any questions? Okay, let me know if you want us to work on another example with substitution or elimination. If not, I would like to talk about a third method. Do we want to look at another example? No, okay. Here's the third method, but this is for, so this is section 6.1, for 3 by 3 systems, solving using matrices, which is not elimination, which is not substitution. Totally different. Totally different. Solving using matrices. And not for systems like the ones we just looked at, 2 by 2, but 3 by 3. More complicated situations.
6.1.
6.1, yes. 6.1. Yes, we'll come back. As I said, smarter people in my department, there's a subgroup, decided that after we do chapter 4, then we do 5.1, and then we continue with 6.1. I was not involved in that decision process. I said, okay. They know what they're doing. And after that, we'll come back to 5.4, 5.5, and 8.1.
That sounds big. I was so confused. I couldn't hear what you said. I thought you said, I didn't think you said 6.1. but I could be wrong.
Yes, 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 that's what it is. 5.1, 6.1, and then we'll come back to 5.4, 5.5, and then 8.1. I'm on the calculus committee, so I was not involved in the decision process for 137 at all. So let me copy a system. So we are on page 620, 630, 631. Okay, allow me to pick an example and then you can pick the next. 29. X plus 2y equals z minus 1. X equals 4 plus y minus z. X plus y minus 3z equals negative 2. Okay. First question I have for you is, what type of system is this? 3 by 3. I see 3 equations and I see 3 variables. Very good. That's my first question. Second question to you is, I don't like it. Why do you think I don't like it?
It's all over the place.
Awesome. So we have to do some work. Good. So let's make sure that it's in the correct order. I'm ready when you are. X plus
2y equals minus z.
very good equals negative 1. So all the effort now was targeting the first equation where you had to put it in the correct order. I can't work with variables all over the place. They have to be in the correct order. Good. Second equation, please.
X minus y.
Awesome. So now the second equation is correctly arranged. X below x, y below y, z below z, equal symbol below equal symbol, and the free term. Very good. The last one is okay. Good. Okay. Like before with graphing, rationals, and other polynomials and so on and so forth, I said the first problem will take forever. The second one will take 2 minutes, and the third one less and less and less. So bear with me. It's a long procedure till I'm done explaining it. Okay, first we will define what it's called matrix of coefficients. So every system has an associated matrix of coefficients. What is a matrix? It's an array of numbers, denoted normally with an uppercase letter, and then brackets. Since it's a 3 by 3, I will have the coefficients of x as the first column. Can anyone dictate the coefficients of y in the first and the second column?
2. 1.
Negative 1.
Negative 1.
Good. And can anyone dictate the coefficients of z in the third column?
1. 3. Negative 3.
Very good. So this is the way we create the matrix of coefficients. For any system, we can create something like this. Okay. After we created this matrix, we have to create what is called the augmented. We are going to do something to this. We are going to augment it. Augmented matrix of coefficients. Yes? You mean this one?
No, and like the A equals the matrix thing.
The negative 3?
Yeah.
From here. The negative 1, the positive
okay.
1.
I thought it was like the negative 1, 4, and negative 2. I was like, so confused.
No, we have not done anything with the free terms. This is just the matrix of coefficients. So 1, 1, 1, 2, negative 1, 1, and negative 1, 1, negative 3. Now the augmented matrix. The augmented matrix will look like this. It's still A with a vertical bar, a lowercase b, and everything in brackets. What does this say? It's the matrix A augmented, meaning attached something else to it. Well, this is another just a column, and that column will be this column. Okay, so equals big braces. I copy the matrix 1, 1, 1, 1, 2, negative 1, 1, negative 1, negative 3. I draw a vertical line after I'm done with the matrix of coefficients. And now I'm going to copy in the last column, negative 1, 4, negative 2. Negative 1, 4, negative 2. Okay, so let's summarize what we did. Number 1, we were given a system 3 by 3. Number 2, we rearranged it because it had to, it needed. Number 3, we determined the matrix of coefficients. Number 4, we determined the matrix of what is called the augmented matrix. Number 5. In number 5, this is the main process, the bulk of the method. In number 5, I'm going to show you some process, and then I'm going to show you that after I apply some operations to this, that's why I put some, I don't know yet, we'll have to talk about it. I will change this augmented matrix into this. And a number here, a number here, and a number here. Assuming I can do that, I will. Assuming I can do that and show you that I can change that matrix into this, my question is, am I done? Let's look at what this one says. What does this say? Don't say anything just yet. What does this say? This says x plus 2y minus z equals negative 1. X minus y plus z equals 4. X plus y minus 3z equals negative 2. So stay with me now. Assuming I say I show you that this can be changed into this. I'm asking you now, how much is x? Thank you. How much is y? How much is z? Aha. But you can say, okay, that's wonderful. What is a, b, and c? I don't know, because I have not performed the operations. I only gave you my target. My target is to create that or change that into something like this. Zeros everywhere, only ones on the diagonal, and then some numbers in the left, in your right column. And then I'm done. I solved the system. But yes, any questions? Okay, but the question is, how do I get from here here? I'm allowed to apply only 3 procedures. Let's list the procedures and then start here and get here. So we can only do 3 things. So what is allowed? Number 1, swap rows. And you can see in a minute. What do you accomplish with swapping rows? I'll show you what I accomplish. But first I have to ask you a question. Let's say I decide to move this row here and move this row here. Swap these two rows. Here's my question. Will that change the solution of the system? Of course not. Right? If I say 1, 2, 3, or if I say 3, 2, 1, 3, 2, 1, or 1, 3, 2, doesn't matter, right? Good. So that's the first option. Number 2. Multiply or divide both sides. I should say a row. That's good enough. But anyway, a row by a non-zero number. Non-zero number. Let's see if that's allowed. All of a sudden, when we solved this problem, we said, let's multiply both sides by 7. Did that change the final solution? Multiplying both sides of an equation by a number, did that change the final solution? No. No, we are allowed to do that. Good. And the final operation, or what is allowed, number 3. This is slightly more involving, but we applied it a few minutes ago. We just didn't talk about it. Multiply a row by a non-zero number and add the result to another row. It's a mouthful. Multiply a row by a non-zero number and add the result to another row. Have we done that? Yes, a minute ago. Let me show you. Here's what we did. We multiplied this row by 7, and after we multiplied it by 7, we added it to this row, and we got this. That's exactly what we did. We multiplied both sides by 7, and we added everything corresponding to this row, and we got this. Okay, ready? Okay, now, it's very easy to mess up this if I do not perform the operations in a particular order. So if I want to get from here, here, I have to show you by hand. By hand. So when we start here, in order to get here, there is a particular sequence of steps, and I cannot mess them up. If I mess them up, I will never get here. And here are the steps. I'm going to copy the matrix here. 1, 1, 1, 2, negative 1, 1, negative 1, 1, negative 3, negative 1, 4, negative 2. The first step is always the one in each column. So this is the one in the first column that I need to stay. So I am going to be using this row, which is called R1, R2, R3. I'm going to use R1, multiply it by what number to add it to the second row in order to get a 0 here. And then what do I multiply the first row by to add it to the third row to get a 0 here? What do I multiply the first row by?
-1.
Exactly. So R1 multiplied by -1 and add it to R2. The same thing for R3. Would you agree?
That's the second line, right?
Yes. So R1 multiplied by -1 plus R3. I cannot write the equal symbol between these matrices. You have to put an arrow, not the equal symbol. They are not equal matrices. Okay. I'm using the first row, which means I have to copy it. 1, 2, -1, -1. Now let's do this together, please. 1 multiplied by -1 added to row 2. What do I get here? 0. Very good. Awesome. Yes. Yes, of course. 1 times -1 added to row 2.
That's -1 plus 1.
Which is 0. 2 times -1, add the answer to -1. Very good. Do you all agree with -3? -1 times -1 added to 1. -1 times -1 added to 4. Let's do this one more time for everyone to see. Ready? Yes?
Yeah.
1 times -1 is -1 plus 1 is 0. 2 times -1 is -2 minus 1 is -3. -1 times -1 is 1 plus 1 is 2. And -1 times -1 is 1 plus 4 is 5. Say it again. Good. Now we are looking at row 3. 1 times -1 plus 1. Agreed? 2 times -1, -2. I should work on this one, I'm sorry. So 2 times -1, -2, plus 1. Very good. -1 times -1 is 1. 1 minus 3. -1 times -1 is +1. Minus 2 is, that's it. What have we accomplished? Let me show you what we have accomplished. I accomplished this. This is done. Now I'm here. I have to accomplish the 1 first in each column, step by step. I'm done with the first column. I cannot go back and change anything there. So now I have to accomplish this 1. Ready? How do I accomplish that 1? I prefer swapping these two, otherwise I'll have to divide both sides here by -3. And if I divide by -3, then I'll have -2/3 and -5/3. I don't want that. And I am allowed to swap rows if I need to. So I'm going to swap now row 2 with row 3. So row 2 becomes row 3 and vice versa. So then the next I have 1, 2, -1, -1. I have 0, -1, -2, -1. And I have 0, -3, 2, and 5. So I swapped row 2 with row 3. I'm still here. I need a 1, not a -1. How do I obtain a 1 right there in the middle? What should I do to both sides of that row? Multiply it or divide it by? That's it. R2 gets multiplied by -1. Perfect. So then 1, 2, -1, -1 is the top row. 0, negative 3, 2, 5 is the bottom row. 0, 1, 2, 1 is the middle row. What did I accomplish? Here's what I accomplished. I have all this column done, and I also have this accomplished. Now I have to work on this, and I have to work on this. So I have the 1. I need to obtain a 0 here, and I need to obtain a 0 here. Obviously, I will have to use row 2 multiplied by something and add it to row 1. And also row 2 multiplied by something else and add it to row 3 in order to accomplish those 2 zeros. So, in order to accomplish the 0 here, what do I need to multiply 1 by? Negative 2, very good. In order to accomplish the 0 here, what do I need to multiply this by? Very good, awesome. So let's do that. Now I copy the middle row. And I copy 1 and 0, 0. Those can never be changed again. Those are carved in stone now. They are done, and nothing will change them. Ready? Let's do this together. 1 times negative 2 plus 2.
0.
Thank you. 2 times negative 2 minus 1.
Negative 5.
Very good. 1 times negative 2 minus 1.
Negative 30.
Awesome. Very good. Well done. It's all like a little puzzle. Okay. Say again.
A little puzzle.
A little.
I do this.
It's the first example. Okay. 1 times 3 minus 3. Very good. 2 times 3 plus 2.
8.
Very good. Awesome. What am I? Here. 1 times 3 plus 5. Very good. Awesome. What did I accomplish? A lot. Here's what I accomplished. Look here. It's not that I only have this done, but now I have this one done. Where is my next step? Exactly. I need a 1 in here. Can I obtain a 1 in here? What should I do to both sides of the third row? Divide both sides by? That's it. So R3 divided by 8. By 8. At this stage, if you look at this matrix, can you already give me Z?
Yeah.
How much?
1.
Exactly. 0, 0, Z equals 1. Okay, so now I have to use R3. Multiply by something and add it to R1. And R3 multiply by something else and add it to R2. What do I multiply by? So what do I multiply R3 by to get a 0 here? Very good. And now I need a 0 here. Very good. I copy the first 2 columns. They cannot change. I worked very hard. I worked in the correct order. Nothing will change those 2 columns ever again. Ready? 1 times negative 2 plus 2. 1 times negative 2 plus 1. Done. Very good. Awesome. 1 times 5 minus 5. 1 times 5 minus 3. What do you expect the solution to be? Say it again. Careful. I have to start from the top because this is corresponding to x. This is corresponding to y, and this is corresponding to z. That's why everything has to be in perfect order.
2, -1, 1.
Okay. Do I trust this? Absolutely not.
Will that work
We
here?
ain't gonna trust it today.
I don't trust anything. So 2, -1, 1. 2, -1, 1. 2, -1, 1. Okay, let's try. So 2 minus 2 is 0. -1 equals -1. Check. 2 plus 1 is 3. 3 plus 1 is 4. Check. 2 minus 1 is 1. 1 minus 3 is -2. Check. Now I do trust it. And I will say yes for sure. So this is the method of matrix. It's really called the Gauss-Jordan elimination method. There is one that is called Gauss. The other one is called Gauss-Jordan. We went all the way with the whole method. Gauss-Jordan method. And it should be mentioned in here. Okay, so we went directly to Gauss-Jordan elimination. We did not stop in the middle. Gaussian elimination is only halfway of what I just showed you. So we went directly to the entire method, the Gauss-Jordan elimination method. And this is 6.1. Of course, we need practice, but once you understand